Very good evening, Kamesh Marty garu. Please unmute yourself, sir. Very good evening.
అన్నా
Hello.
అన్నా ఈ పూజ అయిపోయిందా?
Sir, very good evening, Kamesh Marty garu.
నాకు చిన్నబాబు ఆధార్ కార్డు ఆధార్ నెంబర్ చెప్తారా? చిన్నబాబు తీసుకొచ్చి లేకపోతే చిన్నబాబు కంగారం లేదు.
Good evening, sir. Can you hear me?
Yeah. Very clear, sir. Very clear voice. And very good evening. And thank you very much, sir, for accepting our request. And today we are going to have one session there. And our section chair and our chapter executive members and Uday Kumar, sir, all are there. All are already joined, sir. So within 3 or 4 minutes, we are going to join, sir. Shall we wait for 3 to 4 minutes, sir? Yeah.
Sir, TSN, sir.
Sir. Chakravarti garu.
Shall we start recording?
Already started, sir. Recording start chestam.
Yeah, okay.
Okay, sir. Thank you. Lakshman sir, shall we start? Lakshman sir, shall we start?
ఒక 2-3 minutes వెయిట్ చేయండి. ఇప్పుడే 6 అయింది కదా.
We will start after 2. అలాగే సార్ డెఫినెట్ గా సార్.
இதுக்கு ஆளே இல்ல 35 பேர் தான் இருக்காங்க. தெரியல.
We'll start and
Okay, sir. Lakshman sir, we will start, sir. Okay. So, very good evening, one and all. This is TSN Murthy, Child Communication and Signal Processing Society Joint Chapter, IEEE Vizag Base Section. At the outset, it is indeed a great pleasure and honor for me to be a part of today's technical talk on key performance indicators and optimization of 5G and LTE wireless networks by Sri Kamesh Marty Garu, Verizon, New Jersey, USA. Now, respected guest of the today's function, Sri Kameshwar Marty Garu, Verizon, New Jersey, USA, and our beloved Dr. S. Lakshmi Narayan Garu, Chair IEEE Vizag Base Section, and our chapter executive committee members, Vice Chair Dr. VVS Chakravarti Garu, Secretary Dr. N. Uday Kumar Garu, Treasurer Dr. M. V. Subbarao Garu, members Ravi Garu and Hema Madam, and today program coordinators Dr. N. Uday Kumar Garu and Srimati Hema Madam, other EC members of the Vizag IEEE Vizag Base Section, and dear participants, a very good evening and warm welcome you all for today's talk on key performance indicators and optimization of 5G and LTE wireless network. Thank you very much, Commissioner Matigar, for accepting our request. The chapter is organizing a series of technical talks on recent advances in communication and signal processing areas. We are planning to organize more DLs and international conference in near future also. Now it's my privilege and honor to invite respected our beloved Dr. S. Lakshmi Narayan Garu, Chair IEEE Vizag Base Section, to address the gathering. Sir, Lakshmi.
okay. Dr. Murthy, Dr. Marty, Dr. Chakravarti, and others on board. A good evening to all. It is in fact indeed a privilege for me to join you and hear some crucial talk of Kameswar Marty on this. Really indeed a great pleasure to hear him. I saw his biodata after we have confirmed the talk from him, etc. He is a very good researcher in that area. Therefore, I feel that Marty Garu, I also request you one thing that many of the talks, what happens in India, I think you are aware, they go in the academic direction. They don't go in a research direction. Therefore, I still request you to basically, there are a lot of research scholars, MTech and PG students are there in the team of the 55 people, what I could see. And I request you to, you can give your talk as your style and pattern, but give and highlight where exactly the candidate can concentrate on the research direction or go in kinds of advanced work in that area. Those key points please raise at each slide so that our people will be inclined to do that kind of work and publish papers and future research they can continue. This is my request to you, and I hope that you will do my favor to our students, our colleagues, our delegates over board. Thank you very much, Murthy Garu. Please continue.
Sir, thank you, Lakshman sir, for your nice words. Nice words and a nice rotation. So now it's my privilege to introduce our chief guest, Sri Commissioner Marty Garu, to all. Commissioner Marty Garu is currently working as a business intelligence manager, managing corporate financial reporting team at Verizon, New Jersey, USA. He has more than 15 years of experience in 5G and GSM technologies. He worked in top 3 US wireless carriers for RF design, CS by PS RAN, and PS core performance teams. He has a Master of Science degree in Electrical Engineering from Cleveland State University, Cleveland, USA, and studied Bachelor of Electronics and Communication Engineering at SRKR Engineering College, AP, India. With this nice introduction, now I cordially invite guest of the today's program, Sri Kameshwar Marty Garu, Verizon, New Jersey, USA, to start the proceedings. Thank you, sir. I'm handovering the proceedings to you.
Thank you, Murthy Garu. I'll start sharing my slide.
Yes, sir. You can.
Can you see my slide deck?
Yes, sir. Yes, sir. It is visible, sir. It is visible.
Sure.
Yeah.
So, hello everybody. Today I'm going to talk about these key performance indicators and optimization of 5G and LTE wireless networks. I'll give some introduction related to some of the topics here, like why 5G? Why are we going to 5G? What is the necessity, right? Like we have LTE, which gives us the long-term evolution, which gives us proper like voice and data, information, or like data efficiency. In LTE, basically you get all the speeds whatever required using LTE. Why we want to go 5G? I'll talk on architecture. What is the difference, basic difference in LTE and 5G architecture? Then I'll go with the interface, the LTE versus 5G interface. And sorry, there is 5G architecture again. I'll talk about 5G architecture. This is something, as somebody mentioned, like the area of further research articles you can work on is the 5G architecture. There are like a lot of options in the 5G architecture, like from 1 to 7. I'll go like with a couple of them, and there are several areas where like the 5G architecture, a lot of research can be done. Why in that area? And the next one will be the key performance indicators. The key performance indicators are the ones that we measure basically how the network is performing. This is something like a reference or a base where you can actually go back and optimize the network and check the performance and see where are the opportunities to get a better network, efficient network, wireless network in the whatever like area you're working, like a cluster or any other areas where you can improve the network and bring more and more customers with the maximum coverage, and reducing the call drop, and accessibility, better accessibility and everything. That's again coming to the network optimization, where you can provide the user, the customer, with more opportunities, like better efficient, better network with more opportunities to reduce your resources and optimize the network. And the last topic is, this is something little different than what we have in LTE and in 3G technologies, because different carriers or different wireless networks, or folks, they're choosing different ways to deploy this 5G network in current. If you take any place, either here in US or India or any place, they have a different way of deploying the network, because we have now more opportunities how the way the 5G can be deployed. So I'll go to the first topic, why 5G. So why 5G? 5G, basically, you have 4G today, giving us like high speeds and better voice quality. It's a lot more efficient than previous 2G and UMTS. Why 5G? And we have like similarly we have 4G. We have HD voice. You can download all your files within seconds. Why? What is the necessity of having 5G? So we have like a lot of applications right now. If you go back to, for simple example, like a ATM. When you withdraw your money in the ATM, what happens is it has to like interact with the central system very efficiently, with low latency basically. And these these ATM or like a small devices like a smartwatch or anything, they are called machine-to-machine devices, M2M devices. They have a low latency, and we need to provide higher speeds in wireless network. Terminology we call throughput, which data throughputs. So the user throughput or data throughput, it has to be very, very quick, more efficient, like very faster than what we have. So not only that, like for example, like the automated cars, nowadays, like the software upgrades are done in all these luxury vehicles with a just a sim inside in the car, where it can get the upgrade, the software upgrade within like minutes. So this is done overnight, and this can be like where this is a good example, like where these low power devices and very small or low machine to machine devices can be used, and we have a better latency to get the software downloaded quickly. That's one good example. There are several examples, like say I'm driving, and tomorrow there's a automation of these cars, automated cars. You can so and I need to I don't need to drive, basically. Like the automated cars will come, and this is the future technology where you don't you have an issue with the parking the car in a very dense or like very highly densely area where you don't find a parking. Then there is an idea that came up in an article, saying that, okay, I'll tell the car, it'll come and pick me and it'll take me. I don't, because it's an automated car, I don't need to park a car at the place where I need to. I can just interact with the car directly. So that response, like that communication, should be very quick with the low latency. So this is something that the technology is changing. We are using this technology very efficiently nowadays, so that and communicating with these devices, a lot of devices, so that we can have more flexible and smart devices in our in the environment where we are living right now. So the last is same thing, like ultra low latency communication, same thing. Even there is one good example on that remote medicine. So basically, the doctor who is doing the surgery, he don't need to do the surgery. He can use his technology sitting at home, emergency. He can use the laptop, dictate what surgery can be done using the robotics, like using the robots and everything. So then the communication should be like a very quick, so that they can perform the surgery, and it's the latency or the throughputs should be higher than what we have right now, so that whatever you see will be like immediately the person sitting away from that particular place can see in a fraction of like less, in very milliseconds, basically. So that's like how the technology is evolving, and those are the areas where you can actually use communications, automation, robotics, artificial intelligence. Everything will be coming into this. It's like you are combining, you are taking communications into the next level, where you are interacting with a lot of devices with less throughput and high throughput and low latency. So what is 5G tomorrow? 5G tomorrow, as I said, like we will have, we will have advanced technology, interacting with a lot of devices, communicating with a lot of devices with low latency and high throughputs, and even like the downloading all these movies or anything, it will be like very quick. And all these smart devices, when you guys saw the iPhone and everything, it was like 10 years back. Now within 5 years we are or like less than 5 years we are seeing a lot of devices coming in. Not only the iPhone, we have like a lot of smart devices today, and we are seeing a lot of technology evolution there. So the next slide, I'll try to be a little brief on this one. What is the difference between the LTE and 5G we have? The 5G NR is NR stands for new radio there. So basically, in the LTE, you have the E node B, all node B here. We have S1 interface. S1 interface is the interface that goes between the MME and the mobility management entity, and all this signaling is done here. And this is the X2. X2 is basically X2 interface is the interface between each E node B to E node B. Basically, they are communicating, they are talking to each other. That's the interface there. And S1 interface, the serving gateway. So lot of they're like user plane and control plane. Lot of signaling is done like in LTE, and it is through E node B to MME. MME has the capability to tell that E node B whether this user is authenticated, and all those signaling is done between the E node B and MME. Whereas in the 5G NR, you have the same kind of structure, but we have NG interface and control and user plane interface between the MME and here it's AMF and UPF. It's the same functionality like MME, and UPF is the same functionality. AMF is the control plane, UPF is the user plane function. And here we call G node B, the NR node B, which is called new radio. New radio. That's a terminology that 3GP according to the 3GPP standards. So the architecture wise, the functionality wise, it's the same, but what happens is in LTE, because it's like a macro, you have frequency in say for example, like we'll be using the AWS spectrum, WCS 1900, 850 megahertz and everything. Whereas in the NR 5G environment, there are like at least for here in US, they started deploying in millimeter wave last year, and now we have sub-6, which is almost like 3.4 gigahertz. So it's like almost like in 5G network, it's almost like the area that is covered, the coverage of the 5G network will be very smaller. It's almost equivalent to the Wi-Fi. So you have low area and high throughput, and covers it's a high frequency, so low coverage area. So your throughputs are like way faster than compared to 4G network. Go to the next one. This is the difference in the air interface. What is the difference in 5G and LTE air interface? So in LTE, we have like a fixed bandwidth, basically, very limited bandwidth. But in the 5G, we have like a flexible bandwidth, and the subcarrier frequency is like you can use multiples of those 15 kilohertz, so that you can use. So my simple example is for the subcarrier spacing and everything is like you have a shower, right? You're taking bath, you have a shower. In 4G, it'll be like one stream coming down. Whereas in 5G, it's a multiple streams that are coming down. It's like the massive MIMO concept. MIMO stands for acronym. So it's like a shower, like multiple streams coming at once, and you're using that kind of a interface so that you have better speeds and better accessibility to the network, and the latency will be very low. The TTI, time to interval, flexible. Have 1 milliseconds in LTE, whereas in 5G it will be like a fraction. So again, it's the same concept. You have channel coding, different channel coding, whereas in LTE it has turbo and conventional. The modulation schemes are pretty much same in both. It's just like how efficient the 5G uses all these air interface parameters, so that it can be so fast, better in compared to 4G or LTE. So this is what initial I was explaining in my 5G. What are the uses of 5G? Why we are doing that? So one example here is video games. Like all these video games, interactive video games. Now, before in 4G or LTE, people like you see slow speeds compared to 5G. All these with new resolutions, with high speeds, with HD videos, ultra HD videos, and everything. Your resolution and everything will depend on the latency and throughput again. So to make it faster, we are using 5G technology, and even with the video games, you can play within your phone with all these new video games that are coming with high, like latest technologies. We can use them. The same thing, downloading, it can be fast. Smartphones, new smartphones, lot of applications, usage of those applications will eventually go up. High data usage, 5G helps. This is this one is again the automation, or you can say like say your ambulance, basically, like this essential people who are using this ambulance or like fire trucks or whatever, they have to be informed within a fraction of seconds, so they can come and help you and use this technology in today's day-to-day life, right? So 5G helps that way. So how is the structure? The basic architecture is like the 5G RAN. These cells nowadays, because it covers only like a small coverage area. So you have multiple cells, like multiple sites, multiple cells in a smaller area. So your coverage area will be like more than what you need, like more than like 10 times above than the LTE. And the core network, as usual, the RAN, radio access network, and the 5G core network, and it connects to the internet or data network. So what are the here? Just this. This one is 4G. What are we getting in today's 4G technology, right? 1 Gbps, whereas in 5G it's 20 Gbps. Whereas in user throughput, it can vary. LTE, it may not be 10 Mbps, it goes like way below that actually in like user throughput, because it depends on the noise level and the interference and the area that we depends on the coverage as well. So it may not be 10 Mbps, but we are reaching more than 10 times above that in 5G. And the latency, is like 10 milliseconds, whereas in 5G it is 1 millisecond. Device density, this is something that you cover more devices in 5G compared to the 4G. That is again like how many devices you have per that kilometers and everything, the area. Spectral efficiency, we have 3 times more than the LTE, and the energy efficiency, we have 100 times more than what we have in LTE. This is something I would say like this is the difference between like how the different carriers are deploying the network in current using the current technology. So in US actually we have a standalone and non-standalone. But most of the carriers right now they're going with this non-standalone approach, which is called option 3x. We have option 1, 2, 3, and 3. Option 3 have 3 flavors: 4, 5, 6, 7. So this is something like I would say that area of research. What are the differences? Like where we can, which is the best one, or like we can explore more on other options. So option for existing network, I'll just be here I'll be only touching on the option 4 and option 3x. The standalone is called option 4, which is like you have a device NGRAN, connected to the 5G core and connected to the external. So basically, this is called option 4. Option 4 is like the standalone exclusive 5G network, whereas in non-standalone, the one that is displayed on the bottom, it's like option 3x. Option 3x, basically what happens is you have 5G network and 4G network, but when you set up the call and the uplink, basically the accessibility, it goes through the 4G network and 4G core, but it uses the 4G core. But when in the option 3x, the E node B will be the LTE node will be the master node. So master node, what I mean to say is it dictates, okay, where to go. Okay, stay on my 4G LTE, or okay, this is a 5G device, go on to 5G. So there will be like a like an addition, like a interface between 4G and 5G, so that they can communicate. And this is done in option 3x. We have option 4, as I said, option 5, option 6, option 7. But it depends on the carrier, meaning like who the company, basically what they want to go. It depends. Okay, the company might say, okay, I want to get rid of all this. Like I want to have different 4G network, 5G network. So I'll go with standalone. Standalone, okay, they have to come up with 5G core, deploy all those virtual servers that are going on the cloud, which is this area. Have everything, and then deploy the 5G nodes, E nodes. This takes a lot of time, because it's still like there it's going on, still the technology is coming in, so this will take a lot of time to deploy in the current scenario. So what they did is, okay, why not we just use 4G, and before we get into this virtual servers on 5G core, we'll say, okay, we'll use the 4G core, use the LTE node B, and the device will talk to the LTE node B, and the LTE node B will decide where to go, whether to go into 5G and interact with 4G. There is another option, as I said, like I think it's in option 3B or something, where we are not using it. I can provide those details if anybody wants to get that. But those like have 5G core, and that one they won't have 4G core. The 5G core will change there. So those are like different options we have currently, so that the company can choose whichever is easy from the business perspective. I don't know, Mutir, like I'm going here, but the questions I can get from at the end, right? Or like you
Yes,
want?
sir.
Yeah.
Yes, sir. Actually, we request the participants to post the questions in the chat box, sir. At the end of the session, if any questions are there, we'll discuss, sir. Yeah.
Sure. Okay. I'll continue then. So now the key performance indicators. So when we have a network, we have to know, okay, how my network is working. What are the measures that we can get? Like, what are the things that I can look so that I can say, okay, my network is performing well beyond like the expected targets. So one is definitely the accessibility. You're making a voice call or data call, and you are not able to get the network, access the network. You're in the layman language, you say that, okay, it's you're seeing circles on your screen basically, or your voice call is like, you're hearing that beeping sound, you can't get into the access. That is one thing, accessibility. The second one is retainability. The retainability we call, like in a layman language, is a drop call. Like, okay, I have a drop call here. What are the reasons? Mobility. So you're moving from one location to the other location, and you have to maintain that mobility, and at the same time you need to have your voice and the data call continue to be. It has to continue without any interruption. So what is that called? We call like handover from one cell to other cell. So that is called like overall that comes under that mobility category KPIs. Next is integrity. Okay, a lot of folks or a lot of companies, they look this integrity as only the downlink throughput. So the downlink is something that obviously coming from the side your cell to the user, right? But there are like other throughput as well. Like nowadays, the company started looking into that uplink throughput. Not much research is done on that perspective, because there is a perception when I started, like in my career in 2G, in the GSM technology, like, okay, my downlink is good, uplink will be good. But things are changing right now, because we have a lot of devices, a lot of this social media usage. A lot of folks are uploading these pictures, uploading the videos and everything. Now companies started looking into that uplink throughput as well. Like basically your signal to noise ratio basically should be well maintained, so that you don't have much interference and your uplink is good. So those are something that that things are changing day to day. How the networks are like looking into these key metrics or KPIs to assess their network. And availability is like, okay, how many, say you have some storm or something happen, my network is down, and the availability is like how much your like cells are available for the users. So that is one thing, like 100% available. Or you can take a cluster of cells where out of 100 cells, you have only 99 cells or sites operating with 100% accessibility, or like the user can access. So it's like 99% availability. Utilization. So this is a key metric, utilization, even though it's on the bottom of the list. But the utilization, because what happens is, like nowadays everybody has smartphones, everybody is using these phones, like the data usage is going up. So the wireless networks, all these companies, they started building the carriers, meaning like, okay, I have one carrier with 700 megahertz or 1900, or like, all these ones are added. So they're expanding their network basically based on depending on the measures like this utilization. And not only that, it will decide which, say for example, like you have a big event, a concert or a sports event like a cricket stadium. Okay, now I want to get a coverage or inside the this particular sports stadium. So how should I get that? Like, okay, where to put which area? Say, shall I keep that in my have a small picocell or something near that VIP area or somewhere else. Where is the usage? So these are the things that we need to know to expand or to build a network or to optimize the network. So the key metric is utilization. We need to know the utilization to do those kind of activities. So these are the key metrics which are basically in LTE and 5G. Some of them actually, because the 3GPP standards, still I was working last year with one of the Nokia. They are still working on 5G metrics, especially the integrity KPIs. So the problem here is if I go back here in the non-standalone, the why I said like they're still working, because a lot of carriers, these companies, they're deploying here, at least the non-standalone. So the non-standalone, like either you can measure your throughput or speeds on LTE or on 5G. You can't measure the KPI on both combined, aggregated well. There are some specific reasons, like technical reasons there. Why the reason is like the scheduling, what they call like the scheduling, like how your downlink packets are sent out in the LTE schedules in different way compared to 5G. So the master node, which is on the LTE, it can't look into 5G and tell like, okay, how 5G is NR radio is scheduled, right? So that is a technical problem where you can't get the aggregated throughput for integrity, which is throughput and latency. You can't measure it. And some of other challenges are like accessibility. The accessibility in the if you see in the standalone network which is deployed right now, so the network tries to get onto 4G first, and then if there is any availability of 5G coverage there, then it'll go back and add that request for the resources on the 5G. So basically there is no accessibility in such a way that that the user is directly getting onto the 5G. So that is not available. The accessibility metric, which we say here, even though it's like said S there, but it essentially goes on to the LTE first. Then the accessibility that I mentioned here, yes, is the communication between the 4G and 5G. So because it's a non-standalone. So these are the challenges in like how you look at. And one of the biggest challenge right now for any engineer or any engineer working in his cluster or any area in his area in the wireless network is like, oh, he got to look at like all these KPIs here and here and dig more to optimize and improve the performance of his cluster or his area. So those are some of the challenges. And even in the retainability, the same thing, like the retainability, because the coverage area is small compared to 4G, so you can say the coverage area of 5G will be a subset of 4G coverage area, right? So the challenge will be like if they have any call drop, they actually speaking, it's not a call drop. It will actually downgrade to 4G LTE. It retains the call. It's not a drop call. It goes back to 4G again. So that is something like for 5 in the 5G, the drop call is not actually a drop call, because you still can retain the call on LTE. So even though you have a measure to check how the retainability is there in 5G, it does not mean that it's actual drop call. So again, one biggest challenge is mobility. This is my last topic because this is very important and probably help your research as well. there are like different types of handover, because you're bringing, not only you don't have one technology, you have one other technology. You're combining both technologies. Now you're talking about mobility. So when you move from, it can go from LTE to LTE, it can go from LTE to 5G, 5G to LTE. There are like different combinations in mobility. So what happens in such scenario? Like, what are the types of handover? And I know I'll cover the basics there. Just give an idea how the handover things work there, and types of handover and everything. That's a challenge when we come to the network optimization, because the guy sitting and looking at the numbers or the thing, he got to understand, okay, where it is coming from. And this is something that it's kind of a challenge there as well. Like, where, which way he needs to optimize the network, which side he needs to optimize the network to improve the coverage, decrease your drop call, or improve your accessibility, improve your throughput. All these things matter. Availability, basically, it's pretty straightforward. Like, how many sites are available, as I said. And 5G at this point, it is not deployed everywhere. So it is deployed only in the dense urban areas, because in the rural and suburban areas, basically with smaller towers, it doesn't help. Then at least in here, like we are going with sub-6 carrier, or like a 2.4 or 3.2 gigahertz spectrum, and some areas we are still using the 600 megahertz spectrum. Utilization, that's something you have to measure which site has high capacity, and then deploy the 5G there. It's basically your 4G metrics will be a reference, and the 5G you can deploy there, where like sports or like places, all these locations. So this is option 3x KPI. So you can see in this picture, this is EPC core. That EPC core will be like the LTE core, I would say. Here you have like the dotted line is signaling, and the thick line will be the data, the user plane, basically the user plane and the control plane, right? So we have X2. EPC stands for Evolved Packet Core, New Radio, Option X, 3X, and S1 interface. S1 interface is the interface between NR and EPC. So this is option 3X. This is the non-standalone architecture that they have, that is deployed right now to maximize our resources, LTE resources. At the same time, we use NR radio, the new radio, which is 5G radio. So here you can see the interaction between LTE node and NR node, right? The use to each other. So as I said, like in the previous topic, the call is initiated on LTE network, and if the device is 5G device, we have very limited right now. Companies are the Samsung and all those folks there. Even the Apple, they released like new 5G phones recently. So now the LTE network says, oh, I saw the 5G device. So okay, because the 5G device is in 5G coverage area. So okay, I'll give them the new radio, the 5G radio. That's how they get like connection there, the accessibility connection there. So that connection there. So here at this point, the 5G coverage is very, very limited, even though we have like like few devices, and it's hard to tell how the performance is right now. Like it's like very, very minimal experience even for me. I mean, it's here and there I saw, but to be honest, I didn't see I didn't see everywhere in here in US. Coming back to the drop rate, drop rate is measured both, but again, as I mentioned, the NR radio drop rate is not really a true drop rate. I mean, like true drop rate is not user perceived drop rate, basically. Only whatever, like in LTE, if you drop, that's a really drop call. Data throughput, yes, it is measured, but not the aggregated throughput, as I mentioned. That's a challenge there. And 5G does not support voice in the current release, but in the future release, yes, the still the work is going on, and that is something that probably a research topic for you folks. The voice KPI only it's measured only on LTE, and there are some scenarios where you know we call like switch voice call switch back, all this stuff, like where you are working, you are on LTE browsing, and at the same time you have a voice call. How does it work? So basically, your voice call will still be on the LTE, but your browsing are on 5G network, and you get 5G resources. So that is something that when you switch to 5G, how things change, how the voice works, what are the codecs and everything. Probably that is something like research topic as well. At this point, to be honest, I'm not aware about that too. I never I didn't go through that topic, but that is something that it's again we can go for research on that, how the voice works on 5G standalone. I mean, this is non-standalone, how it works on standalone. So what is network optimization? So basically, network optimization is like these operators, whoever are trying to do, they don't want to lose the customers. They at the same time they want to expand the network, build the network, and provide better coverage, better throughputs and everything, right? So what are they doing? Like what is basically the optimization, and how we can do in there are few different types. One is parameter optimization. Parameter optimization is like changing the parameters. There are like operating voices we call operating system here. Like that one, we can go change the parameters for each cell, each cluster, optimize the network, improve, see different levels. Say, for example, if you want to go from one technology to other technology, and you want to retain the users to a better technology. So how can I do that? I can use the parameters, change the thresholds, and limit them into a certain technology. I don't want to go in too details into that, but that's how the parameter changes are done, so that you can actually get your metrics, improvement in the metrics, as well at the same time, changing the parameters with less efficiency. But this needs a lot of trials. We do a lot of trials before we do parameter optimization. We pick a cluster, then we do trial. Then sometimes this same trial does not work with the other one, like because of the demographic. Like you might have done a trial, test case scenarios and everything in a suburban area or rural area, but the same test case scenario does not work in dense urban. And the there is a perception that because I worked in New York market, like all for all the three carriers, there's a perception that okay, if it works in New York, it works everywhere, the same parameters. So, but again, I still don't believe that. The reason is like in the rural area, like you have like very very like in some other areas, like where you have like one house here, one house there, like you don't need to set the same parameters. But again, the parameter optimization is some like easier, not easier, I would say, like the optimization method where you can just do your optimization with some logic involved. Capacity optimization is like adding your capacity resources into the network. That is again cost based, basically. Even though like it is cost versus like what is the result you get, basically. So you might add like, okay, I'll add like a 5G cell in that particular location where I have a cricket game going on, right? Sometimes they deploy a temporary cell, right? We call like cell on wheel, which is called cow. So for this particular event, so that will suffice the requirement there for that particular day. So do we need that or not? Because you have more users, you are touching your metrics, the accessibility and retainability is going down and accessibility is going up, like 99, like going, I mean, accessibility, I would say like accessibility failure is going up. Then yes, we need something to do on the capacity, and this is the event location. So operators started like deploying the small cells. They're coming with different ways nowadays. That is something that a lot of research is done, like how we can do better in those areas, especially in the event places. A lot of work is going on, and a lot of operators now, they're more focused on these event locations than anywhere else. Again, the next topic, the coverage optimization. It's the same thing, like how the coverage is in those areas. All these optimizations are like especially more focused, especially like, I would say AT&T. AT&T here, it's like that company is more focused on the, the event locations where the events are going on. How can we improve those locations with building new carriers, new sites, and sometimes you don't need, as I mentioned, you don't need like throughout the stadium, specific areas, maybe where the players are, or maybe where the VIPs are, like like different stands, basically. That handover optimization, you're going from one location to the other. What you see is you're driving. Somehow you are on a phone or you're browsing, somebody sitting in the car and like they're browsing and they see, a call drop, or like, the data, like you lost your network, so basically there is a hole between one side to the other side. How can I improve that handover, right? Because you are on a dedicated call, you are not in idle, right? So you're on a dedicated call, you're moving and you have to improve. One way is improving using the parameters to optimize that. The other way is like, if I can do the handover, doing proper handover. Okay, if there is anything that I can have, like basically we will have a coverage plots, and the coverage plots will tell like which area, how the handover can be done. So that's something analysis that is done behind all this optimization, handover optimization. And as well as you should not like overshoot. Sometimes what happens is like you have a site almost like too much height and it's overshooting, so you're creating some other problems. So these are the issues that you see in the real-time network, where engineers try to look at their different KPIs, metrics, drive tests. They do drive tests and everything to solve these issues. So the last topic, I have some other stuff I can talk, like what are the things challenge, the other things that are going at this point after this, maybe help your research. Going back to the types of handover. So as I said, like we have LTE to LTE handover. So this LTE to LTE handover, there it is differentiated in intra or inter. What is intra? Intra is like intra frequency, I mean, and inter is interfrequency. Within the frequency and outside that different frequencies in LTE. So where does that inter and intra come? Because when the carrier, like when in LTE, like for example, all these operators in here, they have deployed different carriers. They have seven, as I said, like 700, 850, 900, 1900, 2300, AWS, WCS, and all this. Like there are 4 or 5 carriers. So within LTE, so all these carriers, when you move based, say 700, obviously you have more coverage. So that is like the one it is used as a coverage area, whereas like the lower ones, AWS and WCS, which are like 21 and 2300 megahertz, they are a little smaller coverage. Those are for more efficient and throughput carriers, whereas 700 is more. 700 helps more for retainability in the LTE. So how we do the handovers, intra and inter handovers. Coming back to the LTE 5G handover. So LTE 5G, it's between LTE and 5G, but again, in LTE, you have 5 or 6 carriers. So you have to make sure that when you have this LTE 5G handover, it's not only you define the parameters and the relations, what you call as handover relations. These handover relations are defined in such a way that you have different combinations, like 700 to 5G, 1900 to 5G, 2100 to 5G, 2300 to 5G, all this time, like different frequency and 5G relation. And even in 5G itself, you have a different carriers as well. That's again like a different combination. So we'll be talking around like almost like 10 relations for each cell. And not only that, you will be talking about intra. Within the LTE, we have more relations. So, the whole perspective of that handover relations, why I had this topic is the handover relations. Before, when we started in GSM, it is just like, we used to have like 20 relations, basically one cell to another cell. That's it. But as we went from 2G to 3G and 4G and 5G, we are complicating, like these handover relations are complicated. So we are talking about like 500 relations for each one cell. And the optimization is getting much a bigger problem when we have these relations. We don't know which relation is missing. And that relation, sometimes you don't know unless you go back and drive in the area and get the feedback and do some analysis and see where are you seeing these drops to add that relation back. So it's as the network is like, as technology is evolving, the optimization, performance, all these areas are getting tough and tough to analyze, getting tough and tough to analyze and solve the issue. So most of the problems that we see, like it's all like kind of a learning process. Like sometimes tomorrow we see an issue which is not known previously, and it's based on the results, the key metrics, the values that we get, or sometimes we see when we drive, engineers drive there, get the test data, get the drive result data, and go back and analyze it, and then put it in an order so that they can see and compare with the KPIs, these results. So it's getting complicated. The last one is 5G to LTE, so it's vice versa, like the second one. So you have like 4 different flavors. On top of that, you have additional carriers. We are talking about like 500 relations or more than that. So we don't know like which one is going wrong, and all these relations should be maintained to have proper mobility, proper retainability, meaning no call drop when you move from one location to other location. And again, at the same point, we can't lose the throughput, because your handover is not properly happening. You lose the throughput. Basically, you have a connection like delayed connection. If it's taking, you're driving basically, and it took some time. Your packets are in a buffer and buffer, and sometimes there'll be a parameter where we set a parameter to wait to have that packet flow so the packet flow happening again. If it doesn't happen with the parameter, you are breaking the connection. You have to reset up the connection again, the data connection again. But say if you retain that call and you're dragging it, your throughput goes down. So you are sacrificing your throughput because you don't have a proper handover set up in your area. So these are the issues with the types of like the handover when you don't do a proper handover optimization. So what's next? So we saw like last 20 years, we saw GSM, UMTS or 3G, LTE, now 5G. What's next? Yeah, the 5G will stay like few more years. LTE will stay for like at least 5 more years, the way it's going on, or and before they shut down 5G. 5G will take over. Maybe the next one might be 6G. But the complications in 5G at this point is because the area of the coverage, and you have small cells like deployed. And imagine like you have a traffic light and the cell is deployed on the traffic light. Those are the ways that our deployment is going on. Sometimes you have a pole, like you have a bridge that is across your like a major road, right, on the top, like a tunnel. They're deploying a small cell. Nowadays it's like very easy to deploy those small cells, cost efficient, and companies are like trying to shift to 5G very quickly so that they can save more money. These deployment, because all these deployments, all these sites deploying in a particular location needs zoning, all the approvals and all those things. But all these small cells in 5G, the pico cells, they don't need like a large requirement, large space. They just need small space, like a box, small box. And they're deploying, imagine, on the traffic lights or like a small poles, anywhere. Like it's very simple to deploy them. So if say imagine within just like 1 kilometer you have like a 10 cells or 20 cells or 30 cells in that area, or 30. I call it cells, but it's a site or cell, whatever like you call. But imagine you have 20 sites or 30 sites in 1 kilometer, or like even more than that. It's hard to optimize that, hard to basically look into the performance of the network and everything. So now this is the area which I'm talking about, like where you can work on your research. So we have some issue. So now because of this, luckily we have that machine learning coming up. So machine learning, so you have to combine the issue or optimize the network, use the parameters and combine them with your machine learning logic, the algorithms basically. You combine, you automate it so that you can use your expertise, right? Where you use the expertise on the technology side, combine with the automation, and use the software to inside the network. The network itself is optimized with the KPIs. So I'm trying to combine this optimization and KPIs using the automation. That's where a lot of research is done. A lot of companies are coming up with a lot of algorithms and everything. And there is a option there's a software like internally built inside the operators like Nokia, Samsung. They're coming with SON, what is called SON, self-organized network. So this takes all the feeds, all the inputs from the KPI stuff, puts everything optimize the network in such a way that it gives like a feedback, like a control system model basically. So takes feed, goes back, and results like within hours goes back into a loop. So that's the whole like thing that is going on, because it's not easy to optimize this network without automation. That's where the lot of research is going on, and as we go on, the same thing goes with 6G if in future. So uh, so you need to, that area you need to have technically strong expertise in understanding the communications language, I would say. On top of that, you need to have like a software language as well. So a lot of companies, they're working into that now. A lot of research is also going on there, like how best we can organize or automate it. Basically, I would call optimization. Self optimization is within the network, how network is doing by itself. So that way, companies, they look less people to sit and look the numbers. They don't need, save the cost savings, and deploy, have an efficient network for without losing more customers, which we call churn. So churn, it will help. So they're ready to decrease the headcount basically, and use these efficient technologies or efficient software to optimize the network. I think I'm done. This is my last slide. We have resources here. These are the sources, like about the 5G and everything. Yeah. Yes, Muthiero, I'm
Thank you very much, sir, for sparing valuable valuable time with us, and a very nice lecture. First of all, there are some questions posted in the chat box, sir. Can I read one by one, sir? Can I read one by one?
Sure.
Yeah, one question from L. Venkat Garu. Actually, he has delivered lecture on 28th of October, sir. Yeah. His question is that there is a rumor that 5G RF radiation creates an effect on human health. Is that true?
It might be. The reason is I'm not aware of that. Might be the reason is these are very small cells, very thin, but the area it covers is very small. The like your Wi-Fi. My understanding is, I don't know about the medical thing, but it might cause little radiation. But I don't think, my understanding is, personally, I don't think it will affect that much.
Okay, sir. Thank you, sir. Some other questions from other participants. So next question is how to measure these KPIs while implementing any modulation technique for 5G physical layer.
These KPIs, whatever I mentioned today, those are from the network perspective. It works like this. So say in simple language, say you have a call setup, right? That will peg a counter, right? Say for 1 hour, for every second the counter pegs. It's basically like the counter. So the network, what it does is like the system, that operating system, that it measures all these numbers, how many counters are pegged. So whatever I explained, it has nothing to do that modulation. It basically, the KPIs is mostly on the network perspective. Again, say if you have a call drop, okay, there are different causes for the call drop. Say, there are different timers and everything involved. Those call drops, actually, whenever you have a call drop, like say the radio timeout, basically the radio, you are in a bad coverage area and you have a radio timeout expiry, right? So that cause code is triggered, and that cause code is as pegged as a counter in the network side. So whatever I'm talking about is the KPIs that are measured towards the network perspective.
Okay, sir. Thank
Nothing
you.
related to the modulation. Yeah.
Yeah. Thank you, sir. One more last question. Like accessibility means quality. How can we obtain this? Is there any relationship with this KPI and bitter rate?
There is actually, you're right. Like the accessibility, we measure at SINR, like signal to noise ratio. Say a simple way of telling is like you have more interference, right, in the area. You're picking the signal from that interference. So it's a signal to noise ratio. If your interference is very high, it's hard to get the signal from that in the uplink.
Yes.
So what happens is in that area, like your accessibility, sometimes you might have seen a good example is uh, you're you're trying to like set up a call, your interference is high, you are like your uplink is bad. Those are the issues where you see the accessibility issues where your interference is high.
Yeah. Thank you, sir. And one more question is also there. From where we will get these 3GPP standards like bandwidth, subcarrier spacing, extra for 5G? So I think he asked about,
Actually, yeah, you can Google it. I mean, there are different versions, to be honest.
Okay.
The 3GPP, you can say 3GPP document, even me, to be honest,
Yes.
there is different versions. And whatever, like, all these topics, each topic is like for us, when we got trained, it is a 10-day event, 10-day
Yes, sir.
training
Yes.
session. So
Yes,
I
sir. Yeah.
covered it in 1 hour. So for each topic, you have in the 3GPP, they gave us a very well documented PDF document. And that is, I would say, like a very good source for any kind of additional information to understand all this, especially the air interface topic. Yeah, you get like extensive information there in the 3GPP document, and make sure that you go with the date to pick the document, because older versions, they change because a lot of changes are happening in the 3GPP side. There's a lot of work going on, so get the latest document to understand, to go through this all this stuff.
Yeah, thank you very much, sir. And well, that's with question and answer. So it's a very motivated session, sir. You have started with the fundamentals of 5G and 5G architecture, then KPI to monitor network performance and network optimization handover, sir. Thank you very much for sparing valuable time. And we are also expecting the same kind of support in new future activities, sir. So we are planning to organize good number of quality events in 2021, and we are also planning to organize some DLs and international conferences, sir. Yeah, thank you very much. Yeah, thank you, sir. And one more. Now I request Professor VVS Chakravarti garu, who is the Vice Chair for ComSoc chapter, speak a few words on this session. Chakravarti garu, please.
Yes, sir. Thank you very much.
Thank you,
Sir, what you said rightly is very good. In fact, if you go through the previous 4 webinars that we have conducted, they were interestingly on 5G, and this webinar is on network side, while the previous one is on user side. The earlier one is on complete system side, the radio gadget side. So we are on the right line. We are conveying. We are doing a good job actually, and we also need help from people like Kamesh Mattigaru, so that we have definitely some good interaction with the industry, and we can help the students and the researchers who are working in 5G. In fact, because we have seen right from the lecture from by professor from Pondicherry University. See, as he mentioned, that 5G is not a small field. It is a widespread field. In fact, it's not like people do coding and say that I am working in 5G, or people do work on these protocols and say that I am working on 5G. And it is not limited to a particular. You cannot really narrow down. While as In fact, what you told, what Kameshwara Garu conveyed today is very interesting. In fact, which has not been introduced to us earlier in a very polite and gentle manner. In fact, it was quite way it generated a kind of interest in us. Further, we need your help, sir. And I also thank Uday Kumar sir in this regard, because who is the man behind this, arranging this particular webinar. And I also thank you, sir, to Sangana. Thank you. Thank you,
Thank you. Thank you, Chakravarti garu, for your nice words. And what Chakravarti garu said, Professor Uday Kumar garu, who has initiated this lecture, sir. So, who is the man behind this event? So, thank you, Uday Kumar, sir. And once again, thank you, Kameshwara sir. Sir, we will keep in touch with you, and we are expecting support from the coming years activities, sir. Yeah, thank you, my dear participants, all of who has attended this lecture, and I think definitely you will get some good kind of research ideas, and you have some. Okay, anyhow, thank you very much, sir. Thank you, one and all. Sir Kameshwara Garu, shall we close the this session? Yeah. Thank you very much, sir. Thank you, one and all.
Yes, sir. I think